Hello and welcome to Math with Mrs. Becker. Today in calculus, we are going to look at a concept called implicit differentiation, which is section 3.3 in the textbook. So far, anytime that we have found a derivative, it's always been directed towards a function. And what that means is that if you graph that function on a coordinate plane, it would pass the vertical line test. We always only had one variable. Well, what happens if we don't have a function? So for example, if you remember from college trig, or if you haven't taken college trig, no, don't worry about it. This is the equation of a circle. Okay, so from college trig, or you could go on to Desmos.com and plug that in. What you would see is that we have a circle that has a center at 0, 0, and it has a radius, which is the square root of whatever this is equal to. So we have a radius of 2. So the center of the circle is right here. If I go up 2, I have a point. If I go to the right 2, if I go down 2, if I go left 2, I have a point. So here's the graph that we have. Now this is not a function because it does not pass the vertical line test. So if I were to try to find the derivative of this, I need both the x's and the y. I can't get away with just having one variable. So this is what implicit differentiation is all about. You find the derivative, but you do need x and y to find the slope, okay? So let's go ahead and look at this. The main thing is, and I know this is kind of funky, this shows you that the rule is the same if you're doing the power rule. If you have an exponent on y, you bring it out front, you keep the y the same, you reduce the exponent. What's different is when you find the derivative of y, you have to attach dy over dx with it. Okay, so for example, if I have y cubed and I want to find the derivative of that, that would be 3y squared, but because this is a y, it's attached to dy over dx. This is connected to it. Where if I had x cubed, the derivative is just 3x squared. So if it's an x, you just get to find the derivative like you typically would. If it's a y, you find the derivative and attach dy over dx, okay? So let's go ahead and we're going to compute the derivative of this thing, okay? This is my circle that I was looking at. So if I want to find the derivative, you just go piece by piece all the way through the entire thing. The derivative of x squared is 2x. Nothing special because that's an x. Plus, the derivative of the derivative of y squared is 2y, but this is a y. So I need to connect it to dy over dx. Equals the derivative of 4 is 0. So again, what I did is I took the equation of the circle that we looked at here. I found the derivative. This was an x term, so I got to just have 2x. This was y squared, so it became 2y dy dx equals the derivative of 4 is 0 because it's a constant. Now your derivative is what you get when you isolate your dy over dx. Okay, so that's how you find the derivative. Step 1, I would minus the 2x. So I have 2y times dy over dx equals negative 2x. It was positive on this side, I minused it over here. To isolate or solve for dy over dx, I have to go ahead and divide by 2y. So here's your derivative, you guys. Dy over dx equals, the 2's cancel, it is negative x over y. That is the derivative of this. Now what I have to do is they want me to find the slope of the tangent line at the point 1 square root of 3. So 1, this is up square root of 3. So there's the tangent line. One thing I'm noticing is that should be negative. And positive 1, negative square root of 3. So there's that one. That should be a positive. Now the way that you find the slope, typically to find the slope, what we had to do is take the derivative and you fill in a value for x. Well, this thing has x and y, so we need both. So what you do is you have dy over dx, whatever the derivative is, but then you need a value for x and you need a value for y. So if I'm trying to find the derivative for the tangent lines that touch at 1 square root of 3 and 1 negative square root of 3, this is what I would do. Here's the derivative. Negative x over y. For my first ordered pair, the x is a 1. The y is a square root of 3. So now I take the derivative and I fill that in. So it's negative 1 over square root of 3. Well, you can't have a square root of 3 on the bottom, so I go ahead, multiply top and bottom by the square root of 3. I rationalize the denominator. This ends up being negative square root of 3 over square root of 3 times the square root of 3 is the square root of 9, which is 3. So that is the slope at positive 1, positive square root of 3. When we looked at that, we said that it should be a negative. Now when I go find it for the other point, it is the derivative. So negative x over y based off of both an x value and a y value. So I have to plug this in. So it's negative 1 over negative square root of 3. Well, negative cancels a negative. Rationalize the denominator. So I have a square root of 3 over 3. This was at this point, we said that our slope, which we just calculated, should be a positive value, and it was. Okay, let's look at the next one. You can do implicit differentiation with the product rule as well. It's the same thing. If you find the derivative of a y, you connect it to dy over dx. Okay, so this is the product rule because I am multiplying two things together. What am I multiplying together? The first thing, f of x is x squared. The second thing, g of x is y to the power 6. So again, the product rule is this. F of x, keep that the same, multiply it by the derivative of g of x, plus the second piece, g of x, multiply it by the derivative of f of x. That's the product rule. We can do that with both x's and y's. We have to for implicit differentiation. So I go ahead, I keep f of x the same, so that's x squared, times the derivative of g of x. That is 6y to the power 5. Guess what? I just took the derivative of a y, so it's connected to dy over dx. Plus, now I keep g of x the same, so that's y to the power of 6, times the derivative of f of x. That's 2x. Equals, now this is equals 1. The derivative of 1 is a 0. So you go ahead and you find derivatives of everything. Now, these are products. I can go ahead and bring this all together. X squared times 6 times y to the power of 5 would be 6x squared y to the power of 5. This is connected to dy over dx. Plus, I can combine these. This is 2x y to the power of 6 equals 0. So if I want to find the derivative, I need to solve for this. So my first step, minus that to the other side. 6x squared y to the power of 5 dy over dx equals, this is positive on this side, so when I move it here, negative 2x y to the power of 6. To solve, I need to divide both sides by 6x squared y to the power of 5. Here is my derivative, dy over dx. I can simplify this. Negative 2 over 6 is a negative 1/3. So it's negative, and I'd have a 3 on the bottom. You cannot have x's on top and bottom. So this is where you subtract. 1 minus 2 is a negative 1, so there's 1x on the bottom. You cannot have y's on top and bottom, so you subtract the exponents. 6 minus 5 is y, or 6 minus 5 is 1, so I have 1y. It's positive, so the y goes on the top. There is your derivative. Okay, so the same thing. It's the normal product rule. The one spot where I had to find the derivative of y, I needed to connect dy over dx. Then from there, this is a product. I can multiply it into one piece. Don't forget it's connected to dy over dx. Here I can multiply it. It was equal to 0 because the derivative of 1 is 0. Now you solve for dy over dx. I minus this to the other side. This is a product, so I had to divide it. This was something we could definitely simplify because negative 2 over 6 can be reduced to negative 1/3. Can have x's on top and bottom, can have y's on top and bottom. You simplify it. This is the derivative of this. Let's look at the back side. Okay, last question, you guys. If you are finding the derivative of something like this, you just got to go term by term. So I'll need the product rule for this. I'll need the product rule for this. This will just be a single term. This will just be a single term, okay? So when I'm doing the first term, this is the product rule because I am multiplying two things together. The first thing I'm multiplying together is x squared. Second thing I'm multiplying is the y. So this first piece is the product rule. F of x, you keep the same, times the derivative of y, which is 1, but it's the derivative of y, so it's connected to dy over dx, plus, now you keep the second piece the same, y, times the derivative of f of x, which is 2x. That's the first piece. Plus, now I'm doing the product rule again. F of x is x, g of x is y cubed. So when I'm doing the product rule, f of x stays the same, so it's x, times the derivative of g of x. This is 3y squared. Oh, I took the derivative of a y. It's connected to dy over dx. Plus, the second chunk for this product rule, keep g of x the same, times the derivative of f of x, which is just a 1, minus the derivative of 3x is 3, equals the derivative of 5 is 0. You guys, this is wild, but we can totally do this. Now this is a product. X squared times 1 is just x squared. That's connected to dy over dx. Plus y times 2x, that's 2xy. Plus 3y squared times x is 3xy squared. That's connected to dy over dx. Plus y cubed times 1 is y cubed minus 3 equals 0. Well, if I am trying to solve for dy over dx, what I need to do is keep these terms together on this side. Any term that does not have dy over dx needs to be moved to the other side. I need to get all of that over there. So what I have here, and I can distribute this out. On this side, I have x squared plus 3xy squared. Those are the terms that have dy over dx. These two terms have that derivative notation. I put them together and I took that out. Now on the other side, this was positive, I moved it over, so it's negative 2xy. This is a positive, so now it's a negative when I move it over. This is a negative, so it becomes a positive. So at this point, I'm right here. When I divide out that dy over dx, what I did is I just created a product. To get rid of this, all you got to do, you guys, is divide it to the other side. Here is your derivative, x squared plus 3xy squared. Ta-da, because this is gone. This is your derivative, and you are done. That is 3.3. I hope you enjoyed learning about finding the derivative of non-functions, meaning that the graphs do not pass the vertical line test. The cool thing is you can now find the derivatives when you have both x's and y's. There are 13 questions that I think are pretty helpful when you're looking at this concept. It's 1 to 25 odds in the textbook, and I will check you later.